Welcome back to Easy Academic. This video in the linear algebra series will give a quick introduction to the idea of a matrix transpose. So, broadly speaking, transposing a matrix flips the rows and the columns. So what does that look like? Let's say firstly, if we have a matrix A of dimension m by n, this would imply that A transpose has dimensions n by m. So if we take a matrix A with dimensions 2 by 3, A transpose has dimensions 3 by 2. So let's show an example of this. If we have a matrix A 2 by 3 matrix A, that is equal to 2, -1, 0, 3, 4, 1. The resulting matrix A transpose, which has its rows flipped with its columns, will have dimensions of 3 by 2, and it will now look like this. It will now be 2, -1, 0, 3, 4, 1. That is with dimensions 3 by 2. So you'll notice that the first row now becomes the first column. The second row becomes the second column. So let's introduce some simple properties of transposition. So first, and most importantly, the transpose of A, B, if we're to transpose this matrix multiplication, it's the same as taking B and transposing it and multiplying it by A transposed. So the important thing to note is that we flip the order of A and B and then we can simply distribute the transpose. And again, it is important that you flip the order because matrix multiplication is not commutative. So B transpose A transpose is not equal to A transpose B transpose. These are not equal. The second property of matrix transposition is that A transposed is equal to A. So essentially, transposing a transpose cancels it out. And so if you have any questions with relation to matrix transposition, feel free to leave them in the comments. Otherwise, please like and subscribe, and stay tuned for more episodes in the Introduction to Linear Algebra series.